All right, this section is the most important first section in probably these first two chapters, because you're going to use this in everything throughout the rest of the year. It's something you did do in 8th grade, you probably forgot. And no, we did it last year in algebra too. So, it's nothing new. But first of all, you're going to see a lot of things called postulates in the book. A postulate is just considered true without proving. Theorems have to be proved. You guys have heard of what theorems are, right? A theorem has been something that they prove is true. A postulate is something like this. There's a segment addition postulate, which isn't on here yet, but you'll see it. It sounds confusing, but it's not. All it is if you've got two segments, if I've got segment AB, and I add on another segment, BC, so if I add those two together, it makes a longer segment, right? And what would you call that segment? AC. Remember, you only use 2 points. If you use 3 points, what are you naming? A plane, right. 3 points are used to name a plane. So if you're naming a line or a ray or a segment, just use 2. So this is just common sense, right?
Yeah.
If you had something else that makes a longer thing, that's why it's a postulate. You don't have to prove it's true. Coordinates, hopefully everyone remembers what a coordinate is, but just to refresh. XY coordinate, x-axis goes side to side, y-axis up and down. So the first number is the x, it's alphabetical order. They're sometimes called ordered pair because they're in alphabetical order. The first one side to side, second one's up and down. So to graph, like if this was point A, you always start in the center, and this is just directions. -2 means you go 2 to the left, there, and you stop there, you don't go back to the beginning. And then a +3, the second number is always up and down. It's positive, so you got to go up 3. And there's the location, that's point A. Everyone remember those?
Yeah.
Good. Remember what the center is called?
The
Origin. So that gets us. The word congruent. Again, this is nothing new, but you probably forgot what congruent means. You last saw it in 8th grade.
Same size, same shape.
Congruent is the same thing. It's the geometry word for equal. If something's congruent, that means it's equal. The word congruent means same size and shape, and geometry deals with shapes. So that's why they use congruent instead of equal. The congruent sign is an equal sign with a squiggly mark above it. Alright? Everyone seen that before? I know you have, you just probably forgot. So when you see congruent for this sign, it's the same exact thing as equal. So congruent segments are just equal length segments. Now this is what we're doing, the distance formula. We did it last year. You probably remember it more from this. If you've got a right triangle, and you know 2 of the legs, do you remember how you can find the length of the third leg? It's a theorem. It starts with a P. Pythagorean theorem. A squared plus B squared equals C squared. A and B are the 2 legs. If I take 4 squared and add it to the other leg squared, it's going to equal the hypotenuse squared. So this is 16 plus 25. That's 41. So what do you got to do to get rid of the squared? Square root it. if you stop there, just use your brain and look at it. Could this possibly be 41 units long if this is 4 and 5? No. So when you square root 41, most of the time, you can just, if it's not a perfect square, if you do this on your calculator, the square root of 41, you get 6.403 and on and on and on. So we could round it if they tell us to round it, and in geometry we most of the time just round it to nearest tenth. Or if it's not a perfect square, you can just write it as square root of 41. Okay? So, if this were on a coordinate plane, this is what we'll be doing in geometry, and like I said, you did this last year. If you've got a segment that's on a coordinate plane, this is the coordinate over 3 and up 1. This is the coordinate left 2 and down 2. What you could do, you don't always want to though, because then you'd have to draw it every time, is you could do what we just did. You could make a right triangle. How long is this leg? 1, 2, 3, 4, 5. How long is this? 1, 2, 3. So you're looking for the hypotenuse. So it's just 3 squared plus 5 squared equals the hypotenuse squared. So it's 9 plus 25, which is 34. And then you got to square root it. So again, you'll get a decimal. So you could either just leave it as the square root of 34, since that's not a perfect square, or round to the nearest tenth, it's 5.8. Now remember this, the hypotenuse should always be the longest side. If you get something that's shorter than these two, you did something wrong. Okay? Now, I said you don't always want to draw the picture like that. So there is a distance formula. Distance equals the square root. Now I'm going to write it how they got it in the book. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now when you see this in any formula, not just this one, if they got a little 2 and a 1 or anything like that, all that means is take the second x minus the first x. It has nothing to do with the value. So what they're trying to say is, if you have 2 x's, like this one has the coordinate A is 3, 1, B is -2, -2. Remember, this is an x and a y, and this is an x and a y.
So when you take 3 minus -2?
Yeah. It doesn't matter which way you subtract them. You don't have to take the second one minus the first one, because you could write this one first. The only reason they put the 2 and the 1 there is because they don't want someone to say, well, I subtracted the x's, but they used this over. They just went 3 minus 3. So that just means subtract the 2 x's. Subtract the 2 y's, add them together, and square root it. So when we do that, x take away x, 3 take away a -2, and then you got to square that, plus y take away y, 1 take away -2 squared, and then you square root it. 3 take away a -2 is 5, because remember the negatives cancel. 1 take away a -2 is 3, and then you square root it, and you get 34, which is exactly what we did over here. So, the distance formula is the Pythagorean theorem. When you go x minus x, all that does is it finds the length of the leg. And when you take the y minus the y, you find the length of the other leg. You guys see the connection to that? So, you really don't need to know that to solve it, but I guess it's helps a little if you know the Pythagorean theorem and the distance formula are the same thing. Got it?
Yeah.
Now, if we were to subtract these the other way, I want to show you that a mistake some people make, or the calculators will make the mistake for you. If I were to go the x minus the x this way, negative 2 take away 3 squared, and then the y minus the y this way, and then you square root it. Negative 2 take away 3 is negative 5 squared. Negative 2 take away 1 is, now if you punch this in like this on your calculator, you're going to get a wrong answer. The reason why, I guess, if you did it exactly the way it shows, you wouldn't. If you put this in parentheses, you wouldn't get the wrong answer. Because there's parentheses here. The reason why is the calculator, if you don't put a parenthesis, they read negative 5 squared, it only squares the 5 and it leaves the negative there. You're going to get an error if you solved it like this. So this is what you got to remember. When you subtract the x's and subtract the y's, if you get a negative, it's going to turn positive anyway because you're going to square it. So, and you subtract them if you do it in your head or do it on a calculator. If you get a negative, just make it positive. Don't worry about the negative. It's going to disappear anyway. The only thing it'll do is it could mess up your calculator. You guys understand what I'm saying? If you forget to put those parentheses in, you're going to get a wrong answer. Okay? Think of it this way too. We're finding distance, right? Can distance ever be negative? Nope. There's no such thing as negative distance. So you won't get negative numbers. So when you subtract them, if you get a negative, just put the positive number down when you're figuring it out. So, like I said, this distance formula is used from this section all the way till the last chapter in the book. It's used all the time. So you definitely need to know how to find the distance between 2 points. Now, in geometry, you do get a formula sheet. Most of these formulas you don't have to memorize. So when I write out a formula sheet, I don't put these 2's and 1's in there. But when you take like an MCA test or an ACT test, you get a formula sheet. They'll have those in there. I just want you guys to realize that really doesn't mean anything. You ever got that? So here was the segment addition postulate that I just showed you. If you take a small segment and add another segment to it, you get a longer segment. Distance, here we go. Here we've got a triangle. You've got 2 problems like this on your assignment. I think it's 2. Yeah. Except they don't have them connected. They just got the 3 dots there. You got to find the lengths of the segments and find which 2 are the same. Actually, you don't have to say which 2 are the same. You just got to find the lengths between all the points. Now, if you ever have I'm just going to draw another triangle on here. If you had to find these 3 lengths, if it's ever up and down or side to side, what's the easiest way to find the distance? Just count it. You don't need to use the distance formula here. This distance is 1, 2, 3, 4, 5. Okay, and same thing if it's horizontal. So, to find the distance from A to B, you gotta go the x minus the x, and again, it doesn't matter what order you subtract them in. -2 take away 3, or 3 take away -2. -2 take away 3 is -5, but I'm gonna disregard the negative and just put 5 squared. Y take away y, 4 take away 1 is 3 squared, and then you square it. Now everyone know where I got these numbers?
But
The
how-
5.
How can you just get rid of the negative sign?
Well, because it's gonna end up being a -5 squared like that. And when you square a negative, what happens to the negative? Turns positive. So that's why I don't want your calculator to mess it up for you, because if you forget to put parentheses and you just put it in your calculator like this, it'll give you a wrong answer. Because it's only gonna square the 5, and it's gonna keep the negative on it. So this turns out to be 25, that's the same one I had before. Plus 9 is 34. So you can just leave it the square root of 34. Because it's not a perfect square. A to C, take the x, take away the x. -2 take away 0 is -2. But again, just put a 2 squared. Plus y take away y. 4 take away -4 is 8 squared. And when you figure that out, 2 squared is 4. 8 squared is 64. 4 plus 64 is 68. And since that's not a perfect square, you can just leave it square root of 68. If you do make it into tenths, it would be 8.2. Then the last length is B to C. So this length was the square root of 34. This length was the square root of 68. This one should be somewhere in between those two, I'm guessing. X, take away x. 3 take away 0 is 3 squared. 1 take away -4 is 5. It's the same one as AB. 3 squared is 9, 5 squared is 25, that is 34. You guys remember doing the distance formula last year? Yeah, no?
Yeah,
No.
So just that's the answer is the square root of 34,
Yeah.
not 34, and not the actual.
No, you can just leave them if they're not perfect squares, but if you want to, it's not gonna be wrong unless they, later on, we do have to do some of those.
So does that mean A, B, and B, C have the same name?
Yep. So this, if you figured out the square root of 34, it would round to 5.8. And so with that, and this one would round to 8.2. We have a few problems like this. First one's easy, second one's a little bit different. Find JL.
You just like that.
You add them up, 19 and 48, the whole distance would be 67. Find QR.
Wait, all they have is 60 minus.
You'd subtract them. The whole thing's 60, this is 35, which means if you subtract that, it has to be 25. Okay? And then we do have a few where they just give you 2 points and you gotta find the distance between those 2 points. You don't have to graph them. You can just use the distance formula. Distance is the x, take away the x, would be 3 squared, plus the y, take away the y, -3, take away -6, sometimes it's the subtraction that gets people. What's that?
3.
Plus 3.
+3, yep. And then, don't forget, you gotta square root it. This is 9, and this is 9, so that would be the square root of 18. It's not a perfect square, so you can just leave that. If they say round to the nearest tenth, the square root of 18 is 4.2. Another sign I should show you, you'll see this. Instead of equal, that's not actually correct, because these are not equal, because I rounded it. They put the curvy lines. Have you seen that before? That sign means it's about. That means it's been rounded. So square root of 18 is about 4.2. You don't need to do that when you're doing your stuff, but you need to recognize it when you're seeing answers. You guys think you got it?
Yeah.
Oh my god, that's weird.